Uh, Today we will start to understand these formulas. Actually, if we see in the first class, what we have seen in one-dimensional consolidation. In one-dimensional consolidation, at the last, at the end of the this equation, we have found some terms, some terminology like coefficient of consolidation and AV, coefficient of compressibility. Okay, coefficient of consolidation. If you see the coefficient of consolidation is the K by MV. You can write. I think it is better if you write, if it is possible at that moment. If you have any copy and pen, you can write coefficient of consolidation. So what are the terms are there? Coefficient of consolidation, coefficient of compressibility, compression index, coefficient of volume change or coefficient of volume compressibility, and the other terms are there, including these, uh, which will come today after some time. So first, coefficient of consolidation. Coefficient of consolidation is the K by MB into gamma W. K is the coefficient of permeability, and MB is the coefficient of volume change. Gamma W is the unit weight of water. So we can write again CV equals to K into 1 plus, uh, actually MB equals to AV by 1 plus E0. AV by 1 plus E0, MB equals to. So we can write K is into 1 plus E0 by AV into gamma W. This formula is very essential to calculate any numerical problem, to find out our final settlement. Actually, our aim is to find out the settlement of the soil. How much the soil has been settled due to load. This is our aim. To find out the settlement value is our aim. Okay. So first, what we'll see, coefficient of consolidation K by MB into gamma W, where MB is the coefficient of volume change, and we can write MB as a AV by 1 plus E0, where AV is the coefficient of compressibility. Okay, then the equation will be K into 1 plus E0 by AV into gamma W. In this slide, already I have sent this slide. If you see in this slide, you can see this equation. Acha. After this, compression index, CC, one of the important terminology. Compression index is the slope of our curve, void ratio versus effective pressure, effective stress. So void ratio versus effective stress, when we are plotted in the log scale. Okay, when we are plotted in the log scale, void ratio versus the effective stress curve, then this slope is represented by the compression index, CC. Okay, CC value, this CC, what? This CC value, compressibility characteristics. Under compressibility characteristics, there is compression index, there is coefficient of compressibility, there is coefficient of consolidation. Just I have told what is the coefficient of consolidation. Now compression index is this slope. This slope is your compression index. Okay, after compression index, coefficient of compressibility is AV. Okay, but what is coefficient of compressibility? Actually, what is the definition of coefficient of compressibility? Already I have told, but again I am repeating. Coefficient of compressibility is the coefficient of it is defined as the decrease in voice ratio per unit increase of pressure. already I have mentioned. This is coefficient of compressibility. Coefficient of compressibility is decrease in void ratio per unit increase of pressure. Decrease in void ratio to the per unit increase in pressure. This is coefficient of compressibility. And this coefficient of compressibility, why it is used? Why it is used in also in coefficient of consolidation. Because mv equals to av by 1 plus e0, where it was used here, coefficient of volume change or coefficient of volume compressibility, mv. Okay, this is another term under compressibility characteristics of soils, coefficient of volume change. This is coefficient of volume change, coefficient of compressibility, coefficient of volume change. So coefficient of volume change is mv, and mv you can represent av by 1 plus e0, av by 1 plus e0. You can see in the slide, av by 1 plus e0. So when mv equals to av by 1 plus e0, then easily we can put, instead of mv equals to av by 1 plus e0. That's why coefficient of consolidation cb equals to k into 1 plus e0 by ab into gamma w. Okay, after coefficient of compressibility, this coefficient of compressibility, coefficient of volume change. What is coefficient of volume change? Coefficient of volume change, we have all the equations, but what is coefficient of consolidation, coefficient of compressibility, coefficient of volume change? Coefficient of volume change actually can be defined, the coefficient as the change in volume of soil, as the change in volume of a soil per unit of initial volume due to a given unit increase in the pressure. Coefficient of volume change is the simple this formula. Okay, mb is the coefficient of volume change. Coefficient of volume change is the change in volume, the change in volume of a soil per unit of initial volume, the change in volume of soil per unit of initial volume due to a given unit increase in the pressure. Okay, this is coefficient of volume change. So what we have now? First we have, suppose from this slide, compression index cc, simple cc. What is cc? Cc is this slope, this is slope. Also we can find out the cc value from various empirical formula. Okay, like cc equals to 0.009 into wl minus 10%. From this formula we can find out the cc, but actual cc is the slope, this slope. Okay, the slope of the curve. This is simply cc. What is coefficient of compressibility? Coefficient of compressibility is av. Okay, av. What is av? Av is the decrease in void ratio per unit increase of pressure. Decrease in void ratio per unit increase of pressure. This is decrease in void ratio per unit increase of pressure. This is av, coefficient of compressibility. Next, coefficient of volume change. What is coefficient of volume change? Coefficient of volume change. Coefficient of volume change is the change in volume of a soil per unit of initial volume. The change in volume of a soil per unit initial volume due to a given unit increase in the pressure. The change in volume of soil per unit of initial volume due to a given unit increase in the pressure. This is mv equals to again av by 1 plus e0. What is av? Av is the coefficient of compressibility by 1 plus e0. So these are very important to keep with us. Without this equation we cannot find out anything in settlement. And finally, after these equations, these three equations, compression index, coefficient of compressibility and volume change, coefficient of consolidation, what we have seen in earlier class, the consolidation settlement. Finally settlement, find out the settlement formula. We can find out the settlement formula or settlement by using two method, that is using coefficient of volume change method, where rho f is the actually settlement, equals to mv into h into delta sigma dash. Okay, this is settlement. mv, in this formula mv is here, so the name of the formula is using coefficient of volume change. Using coefficient of volume change, we can find out the settlement of the soil. Rho f is the settlement, equals to mv, h is the height of the specimen, our soil specimen, delta and sigma dash, incremental pressure, delta sigma dash. Okay, so this one formula, and another formula was final settlement by void ratio. Rho f equals to delta h, changing depth, equals to E0 minus E 1 by 1 plus E0 into H. This is another formula to find out the settlement. One is using volume change and one is using void ratio. And finally we can find out the settlement by using this formula, rho f equals to, but basic equation is this one of the basic equation to find out the settlement, and another this is the another equation to find out the settlement. Okay, so this is, I think this should be clear to you. Without clear, you cannot perform any numerical problem, or you cannot solve any numerical problem without having the proper idea with this equation. So next is, after this settlement, we have, as per our proposed syllabus, there is degree and rate of consolidation. Degree and rate of consolidation. Okay, degree and rate of consolidation. Degree and rate of consolidation. Actually the degree of consolidation we can define using this capital U. Okay, capital U, degree of consolidation. What is degree of consolidation? Now you have these formulas. Okay, CC, CV, AV, MV. Okay, you have this formula. Now also you have the settlement, rho f you have, but there is some terms, that is degree of consolidation. Okay, what is degree of consolidation? Actually, degree of consolidation is the ratio rho to rho f. As you can see, rho by rho f into, it is the ratio rho to rho f. Okay, and expressed as a percentage is termed as degree of consolidation. U, capital U, degree of consolidation. Degree of consolidation means, rho means simple your settlement. Suppose average settlement. This rho is average settlement, and rho f is your final settlement. Okay, this is your average settlement of the soil specimen, and this rho f is the final settlement of your soil specimen. So the ratio between your, you cannot say the average settlement, but it is same thing, average settlement. Okay, average settlement value actually we are taken for this formula. So rho by rho f, rho is the settlement. Only for this formula we have to say settlement to the final settlement, ratio between settlement to the final settlement into 100, that is degree of percentage. But for calculation of numerical degree of consolidation, you will give in your question. When you will solve your question, in the question section, this degree of consolidation value will be given. Okay, you don't need to find out, already it is given in your question. But based on this degree of consolidation, the various various changing can be happen, various changing in formula, various changes in the your numerical can be happen. So this u value, okay, u, when this u value is suppose less than 60%, then formula is different. When this u value, degree of consolidation value is greater than 100, greater than 60, then the value is different. Less than 60, value is different. Okay, after this u, degree of consolidation, okay, degree of consolidation, there is another thing, that is dimensionless parameters called the time factor, time factor, TV, time factor, TV, time factor, because in our consolidation there is permeability. Okay, permeability is the totally depends on your time. So here also in consolidation there is one term, that is time factor. Time is there, t, you can see in this formula t is there, and also one another important term, that is time factor, tv, time factor is there. What is tv? Tv is defined by this equation only. Tv equals to cv. Cv is our coefficient of consolidation. You should keep in your mind all the term: coefficient of consolidation, compression index, coefficient of volume change, coefficient of compressibility. Okay, because anytime anywhere you can be asked what is coefficient of consolidation. In gate exam it is very important. What is coefficient of consolidation? What is coefficient of compressibility? Okay, so tv equals to cv into t by d square. Okay, where d is the drainage path. The drainage path represents the maximum distance which water particles have to travel for reaching the free drainage layer for the present case of double drainage. In our case, what is drainage actually? D. You can see, oh sorry, I have not added the figure of consolidation. Wait 1 minute. Oh, sorry. Just wait. Just wait. In the our earlier classes, in our last classes, uh, what we have seen, we have seen one test video of one our test, that is consolidation test. This in this test you have seen this specimen, preparation of specimen, and you have seen how to set this specimen into this cylindrical mold. This is the complete setup, our consolidation test. Okay, and this is our specimen. In our specimen, both the side of this mold, this is actually ring, this specimen actually, this is a ring, you can see this is actually ring. Okay, both side is open. Normally what we will do, no, what we do, actually we put one porous stone at the bottom side of this specimen to allow to expel our water and air. Also we put another porous stone on the top of our specimen to allow expel air and water in presence of surrounding water. Okay, so these, the both side is open, our specimen is both side is open, but only confined from the lateral direction, only confined from the lateral directions, but both the side of our specimen is open. So drainage is possible from the both the side. This is called actually drainage. This term is defined by our soil mechanics as a drainage of the specimen. When we are allowing to go out the water or air from the soil, that is drainage. In our consolidation test, there is double drainage. Okay, somewhere it was used as a single drainage depending on their setup, but as normally conventional way or in our lab also we have the double drainage system. We are allowing to expel water and air from the sample in both the direction. From the both the direction, the water and air can be expelled out from the sample. So both side is open in our sample, and for that purpose we put one porous stone at the bottom section and another porous stone on the top section. Okay, already we have put it one porous stone in the bottom section. After placing this specimen, also we will put another porous stone on the top. So this is drainage, this is called drainage, simple drainage. So in that case, also time factor, when we are using the uh, time factor equation, so TV equals to CV into T by D square. CV is the coefficient of consolidation, T is the time, D is the drainage path. Okay, and D square, it should be D square. Therefore, the relation between the degree of consolidation U and TV is the, what is U equals to function of TV. Okay, so the degree of consolidation is a function of time factor. The time factor contains the physical constants of soil layer influencing its time rate of consolidation. Time factor is involved in time rate for consolidation. Time rate, this time rate will influence, or this time rate is influenced the degree of consolidation. And what is degree of consolidation? Degree of consolidation is the rho by rho f into 100. Okay, as per syllabus also you can see under this compressibility characteristics of soil, degree and rate of consolidation. This is actually your degree of consolidation U, and rate of consolidation is the TV, time factor. Okay, time factor. After that we can find this TV value, because TV value is important. U value we can find out if we have rho f into 100, but always this, actually this is the expression of U value, but in our case U value is always given. How much your soil is consolidated? 60%, 70%. 70% degree of consolidation. You under 70% degree of consolidation, you have to find your settlement. Under 60% degree of consolidation or less than 60% degree of consolidation, you have to find the settlement of your sample. So but the TV factor also we can find out. TV factor we can find out from this formula. The final formula is K into 1 plus E0 by AV into gamma W into T by D square. K into 1 plus E0 by AV gamma W into T by D square. You should write these formulas. I'll send the PPT also, no problem, but you should write. These formulas are required to calculate our numericals. Okay. So TV time factor is the K, where K is the coefficient of permeability, E is the void ratio, initial void ratio, AV is the coefficient of compressibility, gamma W is the water unit weight of water, T is the time, D is the drainage path. The time factor and hence the degree of consolidation depends upon thickness of clay layer, number of drainage faces, K, that is permeability, CV is the coefficient of consolidation, and magnitude of consolidating pressure and the manner of its distribution across the thickness of the layer. Okay, these things will be very clear, will be more clear in numerical sections. Next, some equations are there for TV. When your U value, your degree of consolidation is less than 60%. Okay, when your degree of consolidation is less than 60%, TV equals to pi by 4 into U by 100 square. This is one formula. And another formula, when your U degree of consolidation is greater than 60%, when greater than 60%, then TV value is minus 0.9332 log 10 1 minus U by 100 minus 0.0851. Also we can write this formula as a 1.7813 minus 0.9332 log 10 base 100 minus U percent. So this is another equation which is used to find out the TV value. That means time factor. To find out the time factor, first we need the U value. U value is less than 60 or greater than 60, and depending on that the TV value will be decided by formula. And there are some in this figure, there are some I taken from some values of time factor for single drainage. Okay, there are single drainage, there are double drainage. This is the single drainage value. You when degree of consolidation is 10, TV value is 0.047. Okay, TV value is 0.003, depending upon various factors, but normally this value also can be given in your question, and we can consider some values already, values are there, we can consider, no problem. But like these values we can see that if your value is U10, then TV is 0.047. if your value U value is 20, TV value is 0.1. if your U value 40, the TV value is 0.221, like that. But there is some cases, but we should not take in your case the cases. There are various cases which will be very difficult for you to handle. So your TV value depending on this U, degree of consolidation. Your time factor value is depending on degree of consolidation. And after that we can you can see coefficient of consolidation may also written as T equals to this value, just this formula we have changed to where this value also. Oh, sorry. This value, this equation, we have changed to t equals to d square by cv into tv. Okay, t equals to d square by cv into tv. So since tv is constant for a given degree of consolidation and given boundary conditions of the problem under consideration, the time required to attain a certain degree of consolidation is directly proportional to the square of its drainage path and inversely proportional to the coefficient of consolidation. Again, I am repeating, since TV is constant for a given degree of consolidation and given boundary conditions of the problem under considerations, the time required to attain a certain degree of consolidation is directly proportional to the square of its drainage path and inversely proportional to the coefficient of consolidation. Okay, in the theoretical analysis, cv is assumed constant although it is a variable quantity. For a soil at a given void ratio, cv increases with increasing magnitude of the consolidating pressure, and hence it should be determined in the laboratory consolidation test for the range of pressure that would be encountered in practice. Okay, so this is another formula, t equals to same formula like this formula we have mentioned. This formula, also this formula we can convert into this, and tv, we know the tv value is the this tv value depending on degree of consolidation, tv value can be changed, and there are number of tv values automatic we can take, or automatically we can get from the numerical problems. Next, from the next day, today's class is I will stop here. From the next day you should present with your pen and paper. Okay, because from the next day some numerical will be there. Actually our soil mechanics 2 is totally based on numericals, and lots of theories also there, theories to understand the theories, theories are there for understanding purpose, and lots of numericals are there. So from the next class you should present with your copy, pen and paper. Okay, I am taking attendance, just wait. Abhishek, anything, do you want to say anything? Okay, just wait. Acha, again my request to all of you, please respond your Google quiz. Google quiz is very important. Actually Google quiz is the formal attendance. Okay, if you don't attend or respond your Google quiz, then you will be suffer. Okay, thank you, you can leave.